Hello everyone, I'm Dr. Gujain. So in this video we will be discussing about SCAPS simulator for photovoltaic device simulation. Okay, so SCAPS stand for solar capacitance simulator. So first thing that we need to see how to set your parameter. A lot of practical uses, like you need to change series resistance. You can refer different research paper and put these values. Okay, 1 ohm per centimeter, 1 ohm is quite right series resistance value. Okay, so we need not to change, and you can change some resistance as well. So for, as you know, for solar cell simulation you need to put some illumination, and that is already set for AM 1.5G. That means air mass 1.5, global radiation, which is 1000 watt per meter square. And the action means what are the things that you want to calculate, like IV, CV, CF, quantum efficiency. So I am just taking here IV. And as you know, on what kind of simulation you are doing. Suppose you are working on thin film CZTS based solar cell, then you know the open circuit voltage would be around 0.9. So you will set the value 0.9, or if you are working on perovskite, so better to do in the range of 1.5. So you can do it 2 and stop after VOC. That means the curve that you are simulating, it will stop after reaching VOC point. It may be 1.1. After that it will not go to this point, from 1.1 to 2 it will not simulate any property. So that is good option. Suppose you are putting 1 volt, and the open circuit voltage of your device is coming 1.2. so it will not go beyond 1, so you will not able to determine open circuit voltage. So it is a better practice to set higher point at voltage range, so that you can put a tick on stop after VOC. So it may be 1.2, 1.3, whatever it is. And the third point is set problem. So go to set problem. This is left contact, and you know light coming from the front contact. Left means this is the substrate. You need not to put the value of substrate and these layers. You need to just put the properties of back contact. In case of CZTS, it's a molybdenum. So you set some values. Layer 1, suppose I am saying this is a CZTS layer, and you can change the thickness and everything, 1.5. okay, and you can add one more layer, suppose cadmium sulfite, and you see the thickness is around a nanometer, around 40 nanometer, and band gap is around 2.27. and you will change the accordingly, electron affinity, carrier doping, donor concentration, because cadmium sulfide is a anti-material, so it is around 10 to the power 16, or I think 17, and the acceptor carrier concentration would be 0, and you add defect and everything from here. Okay, so like this you can add more layers, and what you can do, you can save this whole model with layer and with back contact properties, whatever is given for your device, and you save these properties. And suppose I am saving here test property, device property is a better word, device property. Okay, and you can save individual layer as well. So here what are you saying, seeing is CZTS same material property, then it will show you want to save thickness, shallow doping, and SR recombination. Save everything, and you can save individual material property as well. So suppose I want to save, because later you want to use this material somewhere else, so it's a better practice to save it, and you need to choose some place. Okay, let's save somewhere, and then you can run kind of single shot. What you want to run, what are the things that you want to calculate. As per that requirement, you click on single shot. because this is not we have not put all the values, so it is not coming with practical results or some good values, but it is giving us like values of open circuit, short circuit current, fill factor and efficiency, which is very less because we are using only 2 layer. And you see like there are a lot of things that you can have, like energy bands and carrier density, as like you are going deep down into the device, and current density and everything is there. Okay, so that's a quite bit introduction for SCAPS. So for more videos you can subscribe to my channel. Okay, thank you.